FDM additive manufacturing technology streamlines prototyping and small batch production, saving its users time and overall production costs. Unfortunately, no technology is perfect, and understanding some of the limitations associated with FDM printing will help its users work around these shortcomings. One of the easiest and arguably the most impactful method to improve geometrical accuracy is tailoring the slice height or resolution to fit the requirements of critical features. The biggest misconception associated with the layer height is that a finer layer height will increase the accuracy of the print. Unfortunately, this is not always the case. Selecting a finer layer height will in fact reduce the toolpath's footprint, resulting in the ability to fit material in tighter sections along the XY plane, and can improve the overall surface finish of the part. However, in respects to the Z-axis, this may slightly offset critical geometries. Let's dig into an example to explain this concept better. We want to print this electronics closer, keeping in mind that the trapezoid cutout is a critical feature. We know that our printer has the resolution capacity of 10 thousandths and 7 thousandths of an inch. It is also important to take the Z-axis measurement of critical features, which happen to be 0.38 inches and 0.54 inches respectively. Upon further inspection, you'd be able to notice that both these dimensions are easily divisible by the 10 thousandths of an inch layer height, but not easily divisible by the 7 thousandths of an inch layer height. This will result in the toolpath shifting the top of the cutout by 5 thousandths of an inch and making the base of the cutout higher by 1 thousandths of an inch. This illustrates that the finer resolution may in fact result in the critical feature deviating from their actual position. The most important takeaway is that your design intent should in fact take into consideration the slice height you want to print at if perfect dimensional accuracy needs to be attained. Now let's dig into seams to better understand what they are and how they impact the final part. A seam in FDM printing is a linear blob up the profile of the part that illustrates the location where the toolpath begins and ends. In most cases, the slicing software such as Insight or GrabCAD will do a decent job of hiding the seams by placing them in a sharp corner. However, this is not feasible with some geometries such as holes or round slots. If you are able to post-process the part, the easiest solution is to undersize the hole at the CAD level by about 15 thousandths of an inch in diameter. Then, you can chase the hole with a reamer after the part is printed. However, if this cannot be done, there are some other techniques to mitigate its impact. Another popular technique is to add a corner to the internal diameter of a hole. This, however, is only feasible if the hole is to act as a clearance hole and doesn't need to adhere to precisely fitting parts. In some instances, both GrabCAD Print and Insight can be useful in hiding seams as well. Let's jump into these softwares so we can better understand where to navigate. We'll start with GrabCAD. Begin by inserting your model into the build tray using the Add Models dropdown. Please note, for this to work correctly, you will want to import a file type that is not a body file like an STL. For this discussion, I used a SOLIDWORKS part file type. Now that the model has been imported, select the critical face. In this case, the critical face is the inside of the hole. Next, select Model Settings, then Face, and then finally the Avoid Seams checkbox. This will help reduce the total size of the seam, however, will not completely remove it without risking the integrity of the part. If you have a Fortis system or an F370, you also have the option to use the Insight software to help remove seams. To do this, begin again by importing the model into the software. Once that is complete, you can select the toolpaths, then Setup, then navigate to the Toolpaths Parameter button. This will open the Toolpath Parameter menu. From here, you may select the multiple contours from the fill style, and then check the Link Contours box from the Contours section. This will ultimately function similar to the Avoid Seams box in GrabCAD, and both are an effective solution to mitigate seams, especially along curved surfaces. Next, we will discuss how the corners and rounds can impact both the geometric tolerances and surface finishes of the part. When an FDM 3D printer makes a corner, the head tries to ramp up or slow down, but the acceleration or deceleration of the extruding filament may be slightly out of sync. This can result in chatter marks around the curve. This was less prominent when 3D printers operated at much lower print speed. However, it has been deemed to be a small trade-off for nearly doubling the print speed. In order to mitigate this issue, you can ensure that all your rounds have a minimum radius of 1/10 of an inch. This provides sufficient time for the tool head to ramp up and slow down as it prints. If you are unable to add a fillet due to geometrical conditions, you can also reduce the contour width and add a contour-to-contour air gap of 1/1000th to 2/1000th of an inch. Lastly, if you have a belt-driven system, it is important to ensure that the belts and pulleys aren't worn out or dirty. This can also cause chatter in your prints. Thank you for tuning in, and I hope you are able to apply some of these techniques to improve the overall geometrical accuracy of your FDM prints.